The rocks came from a mine in Gabon, a place called Oklo. But there were no reactors there.
Not man-made ones, anyway.
The numbers didn't lie. A specific isotope, uranium-235, was missing. This only happens inside a nuclear chain reaction. In 1972, physicists found uranium ore from Africa that was strangely depleted, as if it had already been used in a reactor. The core question echoed through labs worldwide. How could a nuclear reactor exist 2 billion years before humankind? The chronicler traces the timeline on an ancient vellum chart. Dinosaurs hadn't even evolved yet. Not even complex cells. He consults his archives, finding geological surveys of primordial Earth. The world was a vastly different, more volatile place. The evidence was buried deep, a secret kept by the planet itself, a puzzle box made of stone and time, waiting to be opened. Every stone carries a story, and this one spoke of an impossible fire, burning in the planet's distant past. The mystery demanded an answer. Teams of researchers flew to Gabon, their mission to unearth the truth of this anomaly. The chronicler turns a page in his great book. A new chapter began, the hunt for a ghost reactor. The air in Oklo was thick with questions. Was this a unique event, or a process that could happen anywhere, even today? The paradox was set. A modern nuclear signature in prehistoric rock. The first act of our great mystery closes. This was no mere academic puzzle. The stakes were enormous, challenging our fundamental understanding of planetary science. The risk? Believing our world was predictable. The reward? Proving that nature's ingenuity far exceeds our own. The investigation at Oklo was a great gamble. They were digging for a whisper from a long-dead geological age. The chronicler shows a scroll detailing the conditions needed for fission. It was a demanding, almost impossible recipe. First, you need highly concentrated uranium, a very rare occurrence in nature. The search for the source began. Second, a moderator is required, something to slow the neutrons and control the reaction. What could it have been? The odds of all three conditions meeting naturally seemed astronomically low. A geological miracle, or something more? And third, there must be very few impurities, like boron, which would absorb neutrons and halt the process. Scientists drilled core samples deep into the Oklo mine. Each one was a lottery ticket, a potential glimpse into the past. The chronicler compares these rock cores to his own records, searching for a match across 2 billion years of silence. Initial findings were confusing. The reactor zones were small, localized pockets, not one massive deposit. Why? But the biggest hurdle remained the concentration of U-235. Today, it's too low for a reaction to start naturally. He illustrates how ancient rivers might have concentrated the uranium ore into these dense, isolated sandstone lenses. What was different about the Earth 2 billion years ago? The answer was not in geology, but in astrophysics. He consults a celestial chart showing radioactive decay rates over eons. The clock was ticking from the moment the planet formed. The first breakthrough! 2 billion years ago, uranium-235 was more abundant, making up 3% of all uranium. The great gamble was on. The investigators had their map of problems. Now they needed the keys to unlock them. So the fuel was potent enough. The first condition of the recipe was met, thanks to the planet's youth. That 3% figure was the magic number. It's the same enrichment level used in many modern nuclear power plants. But what about the moderator? The key to controlling the reaction. The chronicler points to evidence of ancient water. Groundwater would have saturated the ore. This water slowed the neutrons, allowing the chain reaction to begin and sustain itself. With the fuel and moderator in place, 2 of the 3 pieces of the puzzle clicked together. The image sharpened. As the reaction grew, its heat would boil the groundwater away. Without water, the reaction would temporarily stop. Then, as the rock cooled, water would seep back in, and the process would begin all over again. A planetary engine. This unlocked another incredible secret. The reactor was self-regulating. operating in a gentle, natural cycle for millennia. This cycle continued for an unimaginable length of time, perhaps for hundreds of thousands of years. The chronicler estimates each pulse. On for 30 minutes, off for 2.5 hours, over and over. The Earth hadn't just built a reactor. It had built a safe, stable, long-running one. The design was elegant, but there was one final piece of proof required. The smoking gun. Where were the nuclear byproducts? Fission creates other elements, nuclear waste. If the theory was right, these elements should still be there. Scientists analyzed the rock around the uranium deposits, and they found them. Xenon, krypton, neodymium. The isotopic signatures of these elements were a perfect match for the byproducts of uranium fission. The case was closing. Even more astonishing was where they were found. They had barely moved from where they were created 2 billion years ago. The geology of Oklo had formed a near-perfect natural containment vessel for its own long-term nuclear waste. The final lock on the mystery had turned. The ghost reactor was real. But the story wasn't over. This was a profound revelation, not just for history, but for our own nuclear age and its challenges. At least 17 distinct reactor zones have been identified to date, all operating in the distant past. The chronicler's scroll unfolds further, revealing the immense scale of this natural phenomenon. It was a regional event. Each reactor zone had its own unique history, its own power output, its own lifespan. A family of natural engines. The total energy released was immense. Over their lifetimes, they produced billions of kilowatt hours of thermal energy. This ancient power source may have subtly warmed the planet, a gentle geological influence on the primordial climate. Because further investigation revealed, it wasn't just one reactor. It was a network, a prehistoric nuclear complex. He ponders the life that existed then. Simple, single-celled organisms, unaware of the nuclear fires burning deep below them. The discovery at Oklo rewrote textbooks. It proved the line between natural phenomena and technology is sometimes very thin. The story shifts again from discovery to legacy. What happened to these ancient reactors? Why did they stop? The same force that enabled them eventually shut them down. The slow, inexorable march of radioactive decay. The chronicler closes this chapter. The reactors fell dormant, their secrets preserved in stone, waiting for a curious new species. Over millions of years, the fuel became too diluted. The chain reactions faltered, then ceased altogether. The fires went out. The implications were staggering. If it happened once, could it happen again? Scientists modeled the possibility. The answer, they found, is almost certainly no. The Earth's natural U-235 concentration is now far too low. Oklo was a product of a younger, more radioactive planet. A window into a time we can never revisit. The unraveling of the map was complete. Each question had found its answer, each anomaly its explanation. The Chronicle shows how simple geology, chemistry, and physics can conspire to create something extraordinary and unexpected. The investigation at Oklo became a cornerstone of science, a perfect case study written by the Earth itself. It serves as a humbling reminder. We were not the first to harness the atom. The planet itself was. Now we see the grand design. A planetary-scale system, elegant in its simplicity and staggering in its scope. And so, the third act concludes, not with an ending, but a transition to a much larger perspective. It was not a fluke. It was an inevitable consequence of the laws of physics on a young, active world. How to safely store nuclear waste for thousands of years? The chronicler notes that Oklo provides a 2 billion-year-old proof of concept. Geologists now study the site to understand how different radioactive elements migrate through rock over geological time. The story of Oklo is not just about the past. It directly informs our decisions about the future of energy. The reactors went dormant, their energy spent. A silent monument to a time when the Earth itself was nuclear. The chronicler rolls up his scroll. The tale is told, but the wonder remains. The world is older and stranger than we imagine. Every stone carries a story. We only need to learn how to listen to their ancient, silent voices. The Earth keeps its secrets well. But with curiosity as our guide, we can uncover the most incredible tales. This planet has authored technologies we are only just beginning to understand. What other wonders lie buried? The chronicle of forgotten histories is vast. Tell us in the comments what story the stones should tell next. This ancient story has a powerful modern echo. It offers a blueprint for our own greatest technological challenge.